So, Atsum, should we start now?
So we can start if you're ready.
Yeah. Okay. So, welcome everybody to Sitecore User Group India session. Today we have Atsum with us. He is a solution architect at Primit, and he has been awarded as Sitecore MVP for consecutive 3 years, 2018, 19, and 20. Today, he will talk about a use case where JSS, React, Akamai, and Uniform have been used for creating a website with millions of users for tourism agency. So, and if you have any questions, please post it into the chat window to the host of the session, to me at Sama Brijesh. We will answer your questions at the end of the session. Now, over to you, Atsam.
Hello, everybody. Let's start. First of all, thank you for inviting. Very proud to be with you, and also thank you for introduction of myself. Okay, let me share my screen. So do you see my screen?
Yes.
Okay, then we can start. So I'm going to start with short introduction of myself, and my name is Artem Prashkovich. I have more than 10 years programming experience, and since April 2012 I work for Brimit, so where I'm a Sitecore architect, and I have more than 8 years experience in Sitecore, and I'm Sitecore Technology MVP since 2018. And currently, I'm located in Minsk, Belarus. And today, I will share how our team uses JSS, React, Akamai, and the Uniform for creating a website with millions of users for tourism agency. And first of all, a short disclaimer: as long as our customer is national tourism organization, we have NDA that doesn't allow us to share the customer's name and some project details. And the second one, I'm not a front-end and React developer, and probably I will not be able to answer any specific front-end related questions, but I can try at least. And yeah, we can go further with JSS. JSS was announced a few years ago, and I think many of you know what is it and how it looks like. But anyway, I will say a few general words about that. So JSS is or Sitecore JavaScript Services is a toolkit for JavaScript developers, allowing to build a full-fledged customer solutions, single page applications, web apps, websites, using modern JavaScript libraries and framework, React or Angular, for example, and by being completely unplugged from Sitecore. As we can see on the diagram, JSS is based on such services like layout service, GraphQL service, dictionary service. There is also import service. I separated it because it doesn't take a part in rendering process. In case using a code-first approach, this service is used to deploy changes to Sitecore. We also see the config files here, where the JSS app are defined in Sitecore. There are also Node.js server and Node.js view engine, which are used for rendering components based on the data which is provided by layout service. The view engine is used when rendering is performed on the server side rather than on the Node.js server side. but take into account that in both cases, the data for rendering comes from layout service. We can see it here. As we know, Sitecore 10 was released not so long ago. There are not many new JSS features with this release. The changes are mostly related to improved stability and support for new platform features. And the image that we can see on the screen represents Sitecore 10 architecture. There are not a lot of changes. We can still see the same services, such GraphQL layout service, dictionary service, import service. Probably almost of them are here. So we saw all these services on the previous diagram. Sitecore connected all these services in a separate module called Sitecore headless service. This module, previously known as the Sitecore JavaScript Services Server, and provides the server-side APIs and components which are required for ASP.NET Core rendering SDK, which is new and come with Sitecore 10, and JavaScript rendering SDK, or JSS, previously known as JSS. So, do you see my screen again?
Yes, it
Okay,
is fine now.
let's go further.
Yeah.
Um, Now is the time to switch to the main point of presentation, sharing my experience of using JSS on the real project, which is currently in production. So, a few words about our client. The customer had a platform built using Sitecore 7 and was looking to build a new one using Sitecore 9, where Sitecore is used as a headless CMS. It also planned to integrate the new platform with selected marketing technologies in the digital experience platform. So the scope of the project includes migrating content, keeping the existing custom integrations and extensions from the old platform. The new platform includes 4 sites with separate sitemap under separate domains, and each site will have a new design following a modular approach. One of the requirements of the project is that time to interactive should be less than 1 second. The time to interactive metric, or TTI, measures the time a page takes before the user can interact with it. So, in other words, how long before page responds to the click. Almost all architectural decisions are made around this requirement, and I will call this requirement main requirement during the presentation, just to understand what I speak about. And now is the time to switch to our Sitecore infrastructure, not really Sitecore, servers infrastructure, and all our deployments are automated, and we utilize the Edge DevOps for our releases. And the actual server infrastructure consists of 3 groups: QA, UIT, and production. Currently on the screen, you can see our QA server infrastructure, and you see that we have 2 groups: content management group and content delivery groups. So the content management group is the same for all of our uh, servers. I mean, for QA, UIT, and production. And we can see that we have 2 content management servers here and a load balancer between them. There are a few reasons to have 2 CM servers. The first one is we target to support a high availability for all our nodes, including the CM server. And the second one, we have configured to run all our scheduled and heavy tasks on only one CM server, for keeping another one always fresh and available to work with. We also have 2 publishing services. So find out that publishing service can be scaled up automatically. You just need to install additional publishing service instance, and it becomes working automatically. They both use the same publishing item publishing queue, and so process items from the queue together, which makes it much more faster. So also we can see that we have Azure AD integration, ADFS integration. So we have Solar Search server here, and take into account that Solar Search connected only to the CM management group, and our content delivery servers doesn't use Solar at all. So it's also some difference that we have usually on Sitecore. We have backend identity server here, so it's default Sitecore identity server provided by default, provided out of the box. We have two content delivery servers and load balancer, so that's pretty standard. And we have front-end identity server. It is custom identity built on based on the Microsoft identity server. So now we can see the UAT environment, and there is not a lot of differences, only one for sure. We have green content delivery and blue content delivery servers. It is made for blue-green deployments, and nothing interesting else here for UAT. And this is our production infrastructure. Content management group is the same, but we have some difference in the content delivery group. Now we have two servers for each blue and green groups. Again, so it's made for blue-green deployments. And we have the load balancer between the groups, but this load balancer is not really a regular load balancer. Actually, Akamai plays this role, but we will speak about that later. Okay. So, solution architecture. I was thinking a lot what to show on this slide, but our backend part is pretty much conventional and Helix-based solution, where integrations, helpers, basic stuff for features is a foundation layer. Each module in Sitecore represents a feature in solution. A feature always includes a unicorn configuration. Also, it can optionally have rendering contents resolver if component requires a custom one, configs, and other Sitecore related code for preparing data. So I will add more details about most global issues and how we solve them, so at the end of the presentation. And before switching to the front-end solution architecture, I want to go through the definition of code-first and Sitecore-first JSS approaches. In case of using code-first approach, front-end developer works disconnected from Sitecore and defines Sitecore architecture via in-code, component definitions, and root data. Sitecore information architecture is generated via the import process, and this approach is recommended for smaller projects or temporary sites like campaigns, front-end led projects, and micro apps within a large site. In case of using Sitecore first approach, information architecture are created by Sitecore developer, no import utilized in this case. Front-end developer works disconnected from Sitecore and create components and mock root data based on the specification or contracts provided by Sitecore developer. Contract can be defined first, they allow concurrent work, and this approach is recommended for large and complex projects. Organization looking for full control over Sitecore information architecture. So our project is complex. We are definitely looking for full control over information architecture. So Sitecore-first approach is an obvious choice in our case. So now you can see our Sitecore information architecture. So there is nothing difficult, and we have a full control. So using or utilizing the Sitecore-first approach, we have a full control across the Sitecore information architecture, and it allows us to have a content structure we want, any number of pages of page templates with a preset presentation branches with the default data sources. From the Sitecore perspective, it looks pretty standard, and nothing says that it's a headless solution. So our Sitecore part is also built based on the Helix. So we have a project layer, which is represented by sites, including placeholder settings, branches, templates, and content. A module, which can contain more than one component or rendering, is a feature layer, and base templates, data models, integrations, workflows, global settings is a foundation layer. Only one difference comparing with standard Sitecore solution, we utilize JSON renderings, and this type of rendering doesn't require any backend implementation. You just need to put the component name, forgetting this component during the rendering. This field, this name is used to get the JavaScript implementation for the component from the React part. So I put a few screenshots from our sites. I definitely rename them because I cannot share the names of the sites. But so the main idea of this screenshot is to show that we have a pretty standard Sitecore architecture. So nothing unexpected. So nothing says that it is a headless. So we have one more important thing, that we have the global data like articles, events, curators, itineraries, POIs, and these folders contain the items with the presentation with default data sources. So let's say the pages, and then we reuse this data on the our sites. You can see some wildcard item, which means that we will, when somebody will request the item under the articles, so we will try to find this article under the articles folder. So I mentioned that because it's important, and we faced some issues with JSS when we started working with global content. Okay, now we can go further. One more thing that I want to mention, that we have 4 websites, and let's say site 1 have pretty different layout and the domain, and the rest of them, site 2, site 3, site 4, let's say, have the same layout. They have a different number the number of components is the same. They have a different colors theme, and they use the same domain, but each of them use the different virtual folder. Okay, let's go further with our React solution architecture. And we built a slightly different React solution compared to standard JSS. We did it because we had 4 different websites. Some of them have a different layout. We implemented about 150 components. At least half of them are shared and used by each website. The rest of them are website specific. And to avoid component duplication, we separated a component implementation and JSS apps. Eventually, we have the following. We have a UI component React app, which contains and includes all components implementation. I visually separated the components which is shared and the components for the I call it like shared site, but shared site is just components for the site 2, site 3, site 4, and components for the site 1. We have a shared GSS app React project, which is a common for 3 of our sites, and it is very similar to original GSS React app, but has only one difference: it doesn't have a components implementation. Components are included to the app as a npm dependency. And we have site 1 GSS app, which is similar to shared, but have a different layout, implementation, routings, and another dependency to the npm package. So UI components project has two build commands, one for the shared and one for the site 1. The build command uses own export file, I mentioned it here, which includes the list of components that should be included to the package. The difference is in their number. Each of them includes only the components that are required for the specific site. After the build is complete, the code is published to the private agent npm repository, and then when the build of shared app happens, it downloads the corresponding package with the components from the repository. This is really helpful because we have to care of each byte of assets to meet the main requirement. Uh, okay, so and one more thing, when we build, for example, shared GSS app, it gets the list of components, which will include shared components and components for the prepared for this app. Okay, let's go further. All right, now a few words about content delivery network of CDN. And in our case, we use Akamai cache, and it is probably the most important part in trying to meet our main requirement. Akamai is a leading cloud-based CDN service provider for media and software delivery. All of our websites are fully cached by Akamai. I found Akamai to be a powerful tool that, in addition to caching, can manage a traffic route, can be used as a load balancer, rewrite URLs, perform personalization, and other interesting and powerful things. So we can see that we use Akamai at least like a load balancer between our blue and green groups. Akamai help us to implement blue-green deployments. At the beginning, for example, of UAT or production deployment, we force Akamai to route all traffic to the green group using PowerShell command and start deploying to the blue. Once it is deployed, we are able to verify this, and if everything is fine, we route traffic to the currently deployed blue group and start to deploy to the green. At the end, we force Akamai to route traffic to both groups, and in this case, we have a zero downtime during the production and UAT deployments. Traditionally, only static content can be cached on Akamai when it used with Sitecore. Caching images, scripts, and other static files can improve site performance by decreasing the load on the Sitecore content delivery server, but a lot of work still remains for the CD server. any part of websites that uses personalization must be handled by the CD server. This approach appears to be simple. The visitor connects to the Sitecore. Sitecore builds the page, and Sitecore returns the page to the visitor. The problem is that uh, puts a huge load on the Sitecore instance, so then you have to start scaling up or scaling down your environment. It also means that you cannot take a full advantage of CDN, since personalization has to run on the Sitecore instance. The CDN's use is limited to delivering images and other static assets only. But to meet our main requirement, we have to cache HTML as well. Another requirement that we have is to be able to personalize components. And taking into account that Akamai can run personalization on Edge, customer decided to utilize Uniform to connect Sitecore personalization with Akamai. Uh, a few words about Uniform. Uniform connects Sitecore to modern developer tools and leading CDNs. This means new sites can be deployed using Jamstack approach, connecting leading static site generators to Sitecore, MVC, and JSS sites, and deployed to CDN of choice for fastest performance, resilience, and global scale. In the same time, Uniform moves the execution of personalization rules from the CD server to Akamai. Since Akamai can deliver content to visitors much faster than a properly turned up and scaled up Sitecore instance, Sitecore architecture, you end up with the fastest possible personalized Sitecore sites. And to understand how it works, consider the two things that happen when Akamai receives the request. The request is for the page that is currently cached, called the cache miss, or the request is for the page that is currently cached, called the cache hit. And when a cache miss happens, Akamai must make a call to Sitecore instance. This does slow things down, but since the personalization does not run on Sitecore instance, Sitecore is able to handle requests faster than in case of personalized response. So we can see the request from the visitor to Akamai. Akamai checks if cache exists. In current case, it is not. Akamai makes a request to the Sitecore CD server. At the same time, Sitecore get and request personalization rules from Uniform. Uniform provides the rules in which is represent the ECI rules, which can be read by Akamai. Sitecore builds the page and responds to the Akamai. Akamai add data to the cache, resolve context from personalization based on the rules provided by Sitecore and Uniform, and response page to the visitor. So you can see some example of ECI tags. So there is just if-else conditions where you can read the cookie, some values from the header. So you can build your own. You can build your rules not only the data that you can read from the context, from the device, from the headers. You also can put any value to the cookie and then use this value from the ECI tags. And Akamai will read it and build and get content based on the some values from the server. So in this case, for example, when the condition is true, Akamai will make additional request to get additional data from Sitecore, and for sure this request also will be cached. At the end we get all requests cached, and that's fine. Okay, and we get the Akamai cache hit state, and when a cache hit happens, this is where things get interesting, because this time Akamai has everything it needs to handle the request. It does not need to make a call to Sitecore instance, and the result is the fastest possible performance. We can see that Akamai process all request and responds the page just based on the data that it has. Okay, and another thing that I want to say and explain and is our approach to use search on the CD server. And as I said, we don't use Solr there, and in pursuit of reducing a number of server requests, we made a decision to utilize the Algolia search instead of Solr. And the Algolia provides search as a service, offering web search across a client's website using an externally hosted search engine. It provides a very useful API to use it with React. We have another advantage that we have a full control over the items which we need to store in Algolia. So we just store the data that we need. We don't push anything else to the Algolia. It's just keep only the data that we are going to show, which makes the size of index less and improve the performance. And as you can previously see, we have a different type of data such as events, articles, POIs, and other. I mentioned it before. We have a lot of dynamics components to show this data. All components get data to show from the search engine based on the tags selected in the data source. Let's have a look at the diagram, and I will explain how it works. So authors make any changes in content on content management server, then they publish them, and once item is updated in the web database, it will be updated in Sitecore Solr index, and then we have a scheduled task in content management server, and this task is run every 30 minutes. It takes latest updated items from the index, process them, and send to the Algolia. Then we have, let's say, our website where we have a React JSS app. I separated for two groups our components, let's say static components. For example, banner, map, city, it doesn't matter. And we have dynamics components. And when our page is rendering, so when JSS renders a page, it requests a JSON from the layout server, from content delivery server. And so this response will represent a JSON with data for the components, and this response will contain the data, which will enough to build the static components because it's just images. So it is static data. So this is the layout service will respond everything which we need to build these components, static components, and it also will contains the data sources and data for the dynamics components. But this data is represent just for configuration and some values for building the relevant request to the Algolia. Let's say there we have the number of results that we expect from Algolia. There we'll have the template ID that we will use to get, for example, only articles from the Algolia. There also will be the list of tags, let's say, or IDs of items which represented tags in Sitecore to get relevant data. Let's say we want to get all events which will happen in some area. So which means that we will have a tag with the name of the area, and when we will build the components, we will show the events. We just select this tag and we will get the events, relevant events for this area. So it's pretty simple. Okay. Also, we have performance budget, and the performance budget of it is one more important things that allow us to achieve the main requirement is a performance budget, and it defines a page size which guarantees that the page will be loaded faster than 1 second. The performance budget of the initial visible components of the page should be less than 750 kilobytes. So we measure just the size of components that gets initially to the page. So our page can be much more bigger. We can have much more components there, but only the components that we see when we load the page should be less, the size of them should be less than 750. So we utilize the React dynamic import to make the initial page weightless. Each component represents a separate chunk and is loaded dynamically when the component reaches the visible area of the page. We also have implemented a custom workflow state which pass the items through the performance budget validation, and if validation failed, item cannot be published at all. So we also have some table of so where we see how fast the page should be loaded, and we can see that our client expects that the page will be loaded in 1 second only for the fastest network access, so by cable or fiber optic network. So nobody expect from us that the slow mobile internet will load, that you can load this page in 1 second with some slow mobile internet. Okay. We also use Sitecore Forms in our website, and supporting of Forms by JSS was announced along with Sitecore 9.3 release. To be able to use Forms, you have to add the Sitecore JSS Forms and Sitecore JSS React Forms modules for JSS React application, and nothing required from the server side, and it works fine out in the box. We have faced only one issue with the cache of the anti-forage token. The token is unique for each form loading, but we have got it cached and all form submissions were failed. And unfortunately, we didn't find any elegant solution and just exclude the whole page with form from the Akamai HTML cache. So it is how we fix that. Also, one more thing that was not working by default is file upload. So the file uploading doesn't work with JSS at all. We did some workaround. It's also not very simple, and it was not nice solution to my point of view, but we didn't have another way. Okay, So now is the time to speak about the customizations that we did with JSS. And first of all, we extend our layout Sitecore service context. So we can understand the layout service context like a Sitecore, like a standard Sitecore context object when we work with, let's say, with MVC. So it contains some data which is common for all components, which is related to the page. Let's say the editing mode, the current site, current language. So that is pretty standard, but and similar what we have with Sitecore context in .NET. Uh, Also, it is very easy to extend, and we put some configuration data as well to the context object. And so you can see that we, for example, put the Algolia application. So Algolia tokens and keys here, some keys for the Google API, and so on. And all this data, so sometimes I got the question if it's secure to store this data in the context and the JSS output, and all this data are expected to be safe to be included in the front end, and no matter how you include this in your app, this will be discoverable anyway from the JavaScript. So we also put some breadcrumb, some alternative URLs, which is important for SEO, into the context as well. So this is what we and how we extended the context. Now I want to share the difference between rendering contents resolver and component GraphQL query. And so basically there are two ways how we can how we define how we define the rendering and its associated data are serialized. And this is contents resolver, rendering contents resolver, and GraphQL query. So we use GraphQL query for sure. And I've created a JSON rendering component. You can see that here, just standard, nothing. And I don't have any customization by default. And then I set default rendering contents resolver, which serializes a data source item, and if it is set. Then I've created a data source template with 3 fields: title, description, and image, standard fields. Then I created an item based on this template, let's say a sample data source, and fill it with some data. And I have added the component to the page and choose currently created data source item as a data source. And when I request this page from the layout service, I got this data, so that I just filled with data source. It is standard default Sitecore JSS behavior. So just serialize the data source item. So to show a difference with the GraphQL query, I prepare a small GraphQL request. I extended the query with additional data, like with the title of the context item of the context page. I put data source fields here. So you can see title, description, image. So the same what we have by default. Also, I put some dictionaries here. So this is how we work with dictionary. We don't utilize the default dictionary service provided by JSS, just to make sure that we don't receive unnecessary data for us, because the dictionary service responds all dictionaries that it has, but that we have in Sitecore. And but in our case, we just need to separate dictionaries for each component, and we build custom dictionary structure where we define dictionaries for, let's say, for each component. So, and then just requested by Sitecore pass. Uh, this is one more. Okay, one more thing that I have to mention. You can see the JSS key here. So it is uh, default keyword that we can use with GraphQL. When Sitecore read uh, and execute the request, GraphQL request, it replaces JSS with corresponding properties based on the field type. Uh, because, for example, the title, which is a standard single line field, store value in the value property, but image does not have a value property. It has src property with the path to the image. So you don't need to care about the fields where you need to get data from the field object, and you just put JSS and it will be added automatically. It also adds additional data for the experience editor when you are in editing mode. So this is request. So I probably spent maybe 5 minutes, maybe less, to prepare this GraphQL example. Okay, also took into account that we have initial function here. So the name can be, you can use any name here, so it doesn't matter, but take into account that we have two incoming parameters here. It is that data source and context items. So these parameters represent an item IDs of data source and context item. Okay, and when I request the page with this component from the layout service, I got the following JSON structure. We can see the title of the page, home page. It is context item. We can still see the same data source values here, and we can see one dictionary here. So this is that works. That pretty simple to build, and now I decided to implement the same structure using rendering contents resolver, and so it looks like this. So to get similar output from the layout service using the content resolver, at least I need to know the field IDs. Then I need to get data source and data source and context items. Then I need to get fields, need to check if the value exists or not. Then I also need to care about the experience editor mode, because of if it's experience editor mode, we need to add additional data in editable field just to make this field editable in experience editor. And so if we are not in the editing mode, I just simplify the response because I don't want to get extra data from the server. Also, you can see that I don't prepare the dictionaries here. So let's imagine that there should be one more block of code that will retrieve dictionaries from Sitecore. So in my point of view, it's much more difficult. At least you need to build your solution. You need to deploy assembly with the content resolver to the website root. You need to wait while the recycle pull will happen. So that's much more, it takes more time in my point of view. So, and it is less flexible than GraphQL query, but GraphQL query have also some disadvantages. Not really disadvantages, but we faced some issues when we have two templates with the same name. GraphQL doesn't like it. So if you decided to use GraphQL, don't use the same names for the templates. keep your templates unique, and you will not face any issue with GraphQL. And one more thing that probably is need for me in GraphQL is conditions, because by default, or it doesn't have conditions at all. You can then build some if-else structures with GraphQL, but sometimes it would be nice to have. Okay, we also implemented a few custom queries for GraphQL, and the first one is site-specific item query. So we needed to be able to request items by relevant relative passes. Let's say we have 3 websites with standard and default structure. We have configurations, and each site has own article listing button, for example. And by default, you just can request item by full pass, which means you cannot use the same component which reads article listing button, and you cannot use it by default because you need to put full pass here, and which means you will always point to the one item, but you have 3 items each for each site. So we implemented custom query. We just resolve the context site, and based on the site, we just build relevant passes and get our settings. So we use it pretty often. Another thing that we customize is a custom search query, and we did it because by default, GraphQL cannot search by item ID, but sometimes we had to search under the context item, which is a parameter of GraphQL function. And as I previously said, it is represent the item ID. So, and when we want to search something under the context item, we need to extend it, because by default you cannot do that. Another thing that also important to know that we have 2 places where we need to override the item resolving process. When you work with MVC and you want to do something to customize the item resolving process, you just need to extend HTTP request begin pipeline with additional processor, and that's enough. But when you work with JSS, you also need to do the same for the layout service item resolver, so which is MVC request begin pipeline. So take into account and be care that we face the issue when we override the item resolver and nothing happens when we request the item from the layout service. So another issue that we faced, that virtual folder resolving doesn't work by default with doesn't work with JSS. So let's say we have a website com, we have another site B, which is use the same domain but use additional virtual folder, and when we just request the homepage of site A, which is just a slash, it works fine. But when we try to request the homepage of site B, which I expect will be /b/ or just /b, it doesn't work because Sitecore cannot resolve, layout service cannot resolve virtual folders by default. So, and there is 2 ways to fix: extended JSS app to ensure that the ST site parameter is always populated in calls to layout service, to use layout service, and but when you have more than one JSS app, you have to care about it for the each GSS app. So what which means if you have 5, you need to do 5 times the same. So another approach is override a site resolving processor, and it is the way how we did it. And I have a blog post where I prepare the code and show how we did it. So actually, I will share the link in the end of the presentation. And also we faced the issue when we tried to open the page in Experience Editor, and when this page is stored in the global data folder. Uh, because when you open the page in Experience Editor, it still utilizes the server-side rendering and the Node.js view engine to build the components for the Experience Editor. But when GSS builds the page, it always needs to resolve the GSS app, which is part of the configuration, and the GSS app is also always associated with the site configuration. But when you store your item under the outside of the site, which means that Sitecore cannot resolve GSS app because item is outside of the outside of the site tree, and it raised the exception. And so we did some customization to make it working. So this is pretty simple fix. We have the Sitecore context site, always have it, and just based on the context site start path, we try to resolve the Sitecore app, not really Sitecore, GSS app, sorry. So this is what we had, and it is 3 blog posts that related to the code, which is related to the features that we customize for our websites, and so I can share the links in the chat if somebody needs. And probably thank you for your attention. That's all from my side. Any questions?
If you have any questions, please you can post it to chat window. I guess that's it. So yeah, so thank you, Atsam, for this informative session, and we are pleased to have you with us with Sugin. And thank you all for joining. And if you have any question later, you can send it to us on Twitter or Meetup. We
Yeah.
will, yeah, we can answer you for it.
Thank you for having me.
Yeah, thank you all, thank you, Atsam.
Thank you. Thank you all. Bye bye.
Bye.